I've been working on Cassini education and public outreach for the last 12 years, and my son is 12, so pretty much since he was born.
Oh, well, that's fantastic. So basically your entire life, you've been around Cassini.
Yes.
But you certainly have some of the most beautiful imagery provided. How does the public respond to all of that?
Well, the pictures we've been getting back from the mission of Saturn and its rings and its moons, they're just spectacular. And there's really no other way to see Saturn up close than with the Cassini mission. So we've been so lucky for the last 13 years orbiting Saturn. And it's been such an exciting time to be part of space exploration. Enceladus is my favorite. I absolutely love that a moon is making one of Saturn's rings.
And so what's next for you?
Next, I'm going to be working on two different projects. One is looking at exoplanets from telescopes built by amateurs. So that should be really exciting. And then another project I'm working on is the Globe Observer project, where we have people all around the world who are studying Earth science. And when I was a kid, there were 9 planets, and now there are 3,000 planets that we didn't know about when I was my son's age.
Well, thank you so much for joining us. It's a pleasure. Do you have anything you'd like to add about the Cassini mission?
It's really, really cool.
I agree. I think it's one of the most amazing missions we've ever had. Absolutely.
Nice to meet you.
Nice to meet you. And what was your role with the Cassini mission?
I'm actually pretty new to Cassini. I joined as a participating scientist a couple years ago. So I wrote a grant to NASA, and they accepted it, which was great. And then I got to join the science team kind of late in the game, but before it was over. So I work for the Johns Hopkins Applied Physics Lab, which is in Maryland. And we do a lot of work with NASA. And we run some spaceships, and we work with JPL a lot. And so this was my first involvement in Cassini, but I'd been involved in a few other NASA missions as well. But seeing all the cool images come back for so long, it was something that I really wanted to do, was to be involved with this mission.
What was your idea?
My idea was to look at the tiny moons, so not the ones that most people pay attention to, which are equally cool, but the little tiny ones that are irregularly shaped, kind of lumpy, potatoes, and to take all of the images that they've taken with a spacecraft camera and put them together and make their shapes, so to figure out what their shapes actually are from the images.
Okay. Were you involved with the imaging of, was it Prometheus and Pandora?
Yeah, those recent pictures they've gotten with the F-ring flybys are really neat, with Atlas and Pan, and then Pandora, and all those guys are really cool. And they just have interesting features that you don't see in other small bodies, because they're in this ring environment that's totally unusual and really neat. Yeah. One of my favorite memories, I think, was before I was on the mission. I think I was in graduate school, and images of Hyperion came back. And that is one of these irregularly shaped moons. It looks like a sponge. It has these crazy deep craters. It just looks like nothing small body-wise we'd ever seen before. So that was it's always exciting to see new stuff that is totally unexpected. And then with these recent flybys of Pan and Atlas, these ones that look like raviolis, with cracks in the top, it's crazy. It's got all this debris on the outside, but structure on the top, and just seeing those things come back and seeing these new images is really cool.
So what's next for you in this realm of planetary exploration? Do you have anything in mind that you want to see done?
A few things. So I still have some stuff to finish up with these shapes. Getting, all the images are now here, and so everything we'll have for a long time to come is here. So we got to make the best shapes we can. I'm involved with the Europa Clipper mission, and that has not launched yet, and we're in the planning stages. But it's kind of exciting to see the other end of a mission where we're planning out all of the stuff from the beginning instead of seeing what's been done in the end.
Now, what is exciting about Europa? Why look at it?
Well, Europa, we think it has an ocean, which is very exciting. We don't know if it has plumes or not. So Enceladus around Saturn has lots of plumes, and it's active. So probably has some kind of ocean underneath the icy shell. Europa definitely has an icy shell, and we think it has an ocean, but we don't know yet for sure. And so we want to find that out. And if there's life anywhere in the solar system, that's one of the good places to look.
Enceladus so far has been everybody's big surprise of the mission. But in terms of Saturn, how many moons are there, and are there any that we didn't get a good look at that you wish we did?
Gosh, there are lots of moons. I don't even have the right number. There are tens and dozens of moons around Saturn. All of them that we didn't look at, of course. I think...
So we got to go back to Saturn to keep imaging.
Of course, yeah. Well, there were ones we didn't even discover. There were ones we only saw from afar. Daphnis, that one that's ripping the rings out of their orbits, is so cool, but we only got one kind of decent view of that. It would be really neat to see that from the other side, and we got surprised by so many different moons that we had never seen before. Just imagine the ones that are still there that we hadn't seen and what they look like is fun to think about. Yeah.
It was almost 7 years, about 6.7 years to get to Saturn, with a lot flybys of Earth, Venus a couple of times, and Jupiter before getting to Saturn. But Linda and I were thinking, while it was in the inner solar system, still winding up for the pitch out to Jupiter, you know, if it runs into an asteroid, we're both out of a job at the same time. So I went back to what I was doing before I worked on Cassini, which was thinking up new missions. So far the score is 6 or 8 for us and 0 for the asteroid, so we're doing well.
That's excellent to hear. And Cassini, of course, has been a long mission and has been at Saturn quite some time taking measurements. Did it take any measurements on the way there?
Oh, yes, indeed. Some of it, they needed to calibrate their instruments. And so when you'd fly by Earth, you know what Earth is like. You point your instruments at Earth and get calibrations of your instruments. Flew by Jupiter, and we got some really good data at Jupiter, some images, and was able to help the Galileo mission, which was still at Jupiter at the time, and make the measurements of what the solar wind was doing outside of Jupiter's magnetosphere, while Galileo was inside the magnetosphere. See what the solar wind was doing to the magnetosphere.
So what was the most exciting part of the Cassini mission for you?
Discovering the plumes at the south pole of Enceladus, and then figuring out that the reason those plumes are there is that there's a liquid water ocean under that essentially global ice cap around Enceladus, and that, you know, that what's in that stuff is the kind of stuff you'd expect if there were life there. There's no indication that there is life there, but there's carbon, hydrogen, nitrogen, oxygen, the big four. It's salty. We know that there are hydrothermal vents on the floor of the ocean there, and here on Earth, when you have hydrothermal vents, it just teems with life all around it. And so people are thinking, wow, this is a really good place to look.
Now, Titan could also be a candidate perhaps for a different kind of life. I always thought that was interesting, perhaps using the hydrocarbons that are on the surface there. What do you think about that?
It would be a very different kind of life. The life that we have here on Earth is all based on water. Wherever you have water, you have this life, the Earth-like life. But it has to be based on water. If there's no water at all, we don't find life unless it's in a dormant form, waiting for some water. And water is a very polar molecule. It points in one direction with its electric field because of the atoms that are in there. But at Titan, it's methane, which its atoms balance out. There's no net electric dipole, and so it's a very different kind of liquid from liquid water. You'd have very different kinds of things that go through the reactions to make some kind of life form there than you have here at Earth. If you go deep enough on Titan, though, and when I say deep enough, maybe 30 miles, 50 miles, 100 miles, you get into a liquid water ocean. Now, there's a lot of ammonia and other things in that ocean. It's probably salty too, but you get into liquid water, so maybe there's life at Titan 100 miles down.
So what steps do you think we ought to be taking next to investigate Saturn and the moons that are there?
Well, we actually have some missions that have been proposed. They haven't been accepted, but they've been proposed to go back to the Saturn system. One, to go through the plumes of Enceladus again with instruments specifically looking for life molecules. There's others, one that I know is going to Titan to look at Titan more closely and see, well, what kind of things could be going on there that might be life-oriented, and also doing some geophysical work at Titan. That Titan, Enceladus, the whole Saturn system left the science community with plenty of puzzles to work on.